Get ready, folks, because today we're taking a deep dive into a really fascinating topic, universal emergence. We're going to be exploring how everything around us, from the stars in the sky to life itself, emerged from simpler beginnings.
It's really a journey through time. Yeah. Starting with the Big Bang and kind of tracing the emergence of increasingly complex structures and systems, like layer by layer. Yeah.
And our guide for this journey is The Emergence of Everything by Harold J. Morowitz.
All right.
And he lays out, get this, 28 steps of emergence.
28 steps. Wow.
We've also got some really fascinating scientific papers and historical accounts to kind of add into the mix here.
Yeah, we might not get through all 28 steps today, but we'll hit the highlights.
Yeah.
The most mind-blowing ones, for sure. The ones that really show off how powerful this concept is in explaining how the universe ended up the way it is now. You know, this wonderfully complex place we live in.
Okay, so let's start maybe by really unpacking this idea of emergence.
Yeah.
What does it actually mean?
So emergence is basically the idea that new properties and complexities can kind of just arise, like out of the interaction of simpler components.
Okay.
You know, it's kind of like baking a cake.
Okay.
You wouldn't think that flour, eggs, and sugar would taste very good on their own.
Right.
But when you put them together, you get something completely new and delicious.
So it's not like just putting things together, right? It's about how those things interact with each other and create something greater than like all the different parts.
Exactly. And you see this principle happening at every level of the universe. I mean, you see it from the tiniest subatomic particles
Wow.
all the way up to, you know, like the human mind.
Okay. Yeah, now I'm starting to see the big picture here.
Yeah.
So let's start at the very beginning,
Okay.
the Big Bang.
Right. So the way scientists understand it now is that the universe began in this really hot, dense state, basically like a soup of subatomic particles and energy.
Okay.
And as this soup expanded and cooled, the first structures started to emerge.
So how did we go from this like chaotic soup to something organized like stars and galaxies?
Well, it all comes down to, and this might seem really insignificant at first, but density fluctuations. Just imagine that soup wasn't completely the same everywhere.
Right.
Like there are some areas that had a few more particles clustered together than others.
Okay, I can picture that. So how did these little clumps of particles become the seeds for, well, everything?
Well, those areas that had a slightly higher density, they also had a bit stronger gravity. And gravity, we know, pulls things together.
Right.
So over these huge, vast periods of time, these clumps attracted more and more particles. They eventually became these huge clouds of hydrogen and helium.
Okay, so we've got these giant gas clouds.
Mhm.
How do those turn into stars?
So as these clouds collapse under their own gravity, the pressure and temperature right at their cores, they increase like crazy.
Okay.
Eventually, it gets to a point where nuclear fusion just ignites.
Okay.
And boom, you've got a star.
Wow, so we've gone from a chaotic soup of particles to giant blazing stars.
Yeah.
And it's all thanks to gravity and a little bit of randomness.
Exactly. And it's fascinating to think about how those tiny density fluctuations, you know, just these really small variations in the early universe, play such a huge role in shaping everything we see today.
Yeah, it's like those tiny ripples spreading out from a pebble dropped into a pond.
Yeah.
Just amazing. Okay, so now we've got stars, but we're still missing a pretty important ingredient here. The elements that make up our bodies and pretty much everything around us.
Yeah.
Where'd those come from?
Yeah, that's where things get really interesting. We are literally made of stardust.
What?
Yeah, the elements in our bodies, our planet, you name it, they were all made in the hearts of stars.
Hold on, so stars are like giant element factories.
You could say that, yeah. It's a process called nucleosynthesis.
Okay.
Stars are basically giant fusion reactors. They're smashing hydrogen atoms together to make helium, then helium into carbon, and so on, creating heavier and heavier elements.
So all those elements on the periodic table, they were created inside stars. That just blows my mind.
It is pretty wild. And think about this.
Mhm.
The calcium in your bones, the iron in your blood, it all came from a dying star.
That is such a cool thought. So we've gone from a universe of hydrogen and helium to one with a whole periodic table of elements, and it's all thanks to these stellar furnaces. But how do those elements get from being trapped inside a star to becoming part of, I don't know, planets and eventually us?
Well, when really massive stars die, they explode in these spectacular supernovae, and when that happens, they scatter all these newly created elements out into space.
Okay.
And then over vast stretches of time, all these particles, dust, gas, debris, they start to clump together under the influence of, you guessed it, gravity.
So it's another one of those cosmic dances of gravity and matter.
Exactly. And that's where this tiny little rule from quantum mechanics, the Pauli exclusion principle, it comes into play again. This principle determines how electrons are organized around atoms, and that affects how atoms bond together to make molecules.
Okay, so this tiny rule from the quantum world is now shaping planets.
Exactly. And these chemical bonds, they influence how planetary systems form, what planets are made of, and ultimately the conditions for life itself.
So we've gone from a universe of hydrogen and helium to a universe with a whole periodic table of elements, and then those clump together to form planets. I mean, that's pretty impressive for just a few steps of emergence.
Yeah.
But we're still missing the most important ingredient for our story: life.
That's right.
How do scientists think life actually emerged on a lifeless planet? Was it just a random fluke? Or was there some sort of deeper logic going on?
That's a question scientists have been trying to figure out for ages.
I bet.
We don't have a definitive answer yet, but we do have some pretty cool clues. Just picture the early Earth, a hot, volatile place, very different from the Earth we know today.
Okay, I'm picturing volcanoes, oceans, a very different atmosphere. Not exactly a welcoming place.
No, not really.
Yeah.
But amidst all that chaos, something amazing was happening. The energy from the sun and the Earth's interior, mixed with the chemicals in the early atmosphere and oceans, they all created a kind of crucible for complex organic molecules to form.
So essentially, life arose from a chemical soup powered by the sun and Earth's own energy.
Exactly. And the key to all this was the emergence of metabolism, that complex web of chemical reactions that powers life.
Okay, so metabolism is like the engine of life, driving all the processes that keep an organism alive.
Yeah.
But how did such a complex system emerge from, I don't know, simpler chemical reactions?
Now, this is where it gets really mind-blowing. It seems like early metabolic networks had this incredible ability to self-organize and even catalyze their own formation, like a chemical bootstrapping process.
So it wasn't just a bunch of random reactions, but some kind of deeper logic, like a
Right.
chemical intelligence, that guided the emergence of life. That's incredible.
It really is a remarkable phenomenon. And while we're still figuring out all the details, the emergence of life from non-living matter really shows the incredible creative potential of the universe.
I'm already feeling overwhelmed by how much we've covered, and we've only scratched the surface. What's next in this grand story of emergence?
Well, next, we'll explore how those early life forms evolved and diversified, which eventually led to all the incredible organisms we see today,
Okay.
including us, of course.
Okay, I'm on the edge of my seat. Let's dive into the next chapter of this mind-blowing saga. Welcome back to our deep dive into universal emergence. Last time, we traveled all the way from the Big Bang to the formation of planets, and we even touched on that incredible mystery of how life itself arose from non-living matter.
It's a journey that really shows us how complexity can emerge from simplicity
Yeah,
over and over again at every level of the universe.
it really does. It stretches the imagination. So we left off with the emergence of those very first life forms, those single-celled organisms. What happened next? How did we get from those simple organisms to, all the incredible diversity of life we see today, from, I don't know, towering trees to the intricate ecosystems of coral reefs?
Well, that's where the power of evolution comes in. Over billions of years, through variation, selection, and inheritance,
Right.
life has diversified and adapted to fill every niche on our planet.
So evolution is basically a story of emergence playing out over, like, eons.
Exactly. Each new adaptation, each new species,
Yeah.
it represents a new emergence, a new layer of complexity building on what came before.
This reminds me of something I read about the evolution of the eye.
Okay.
It's such a complex and intricate organ.
It is.
How could something like that possibly emerge through, like, random mutations and natural selection?
Yeah, that's a question that puzzled even Charles Darwin.
I bet.
But what we've learned is that the eye, like many complex structures, didn't just appear overnight.
Right.
It evolved gradually, step by step, with each small improvement giving a slight advantage. And then natural selection would favor that.
So it's like building a complex machine,
Yeah.
piece by piece,
Uh-huh.
with each new part adding functionality and complexity.
That's a great analogy.
Yeah.
And the eye is just one example. Think about wings.
Yeah.
or lungs for breathing air, or the intricate dance of pollination between plants and insects.
Amazing.
All examples of emergence in action shaping the natural world.
It really is mind-boggling to think about all those connections,
It
the
is.
interdependencies in the web of life.
Absolutely. And the emergence of ecosystems is another fascinating layer of complexity. You've got different species interacting and co-evolving, forming these intricate webs of relationships
Right.
that shape how energy and nutrients flow through the biosphere.
So it's not just individual organisms evolving, it's entire communities of organisms evolving together
Yeah.
into these complex, interconnected systems.
Exactly. And these ecosystems, they even shape the physical environment. They influence the climate, weather patterns, even the composition of the atmosphere.
Okay, I'm starting to see how this concept of emergence really ties everything together. But what about us? Where do humans fit into this whole grand story of universal emergence?
Well, remember from our last episode, the emergence of primates, with their grasping hands, forward-facing eyes, and larger brains that set the stage for our own lineage to evolve.
Right, so our primate ancestors were already pretty special. What were some of the key, emergences that led from those tree-dwelling ancestors to us?
One of the biggest was bipedalism, basically walking upright on two legs.
Okay.
This freed up our hands for carrying tools and food, which allowed us to exploit new resources and adapt to new environments.
So walking upright was like a major turning point.
Absolutely. And it also had huge implications for our brains. When our ancestors became more bipedal, their pelvises had to narrow,
Okay.
which, constricted the birth canal.
Oh, I see where you're going with this. So babies had to be born earlier with smaller, less developed brains?
Exactly. And while that might seem like a bad thing, it actually had a profound impact on our evolution. Well, human infants were now born helpless and dependent, needing more care from their parents.
So this pushed our ancestors to become more cooperative and
Yeah.
social, right? To develop stronger bonds and better ways of communicating.
Precisely. And that created a need for larger, more complex brains that could learn, solve problems, and navigate social interactions.
So it's another example of how a seemingly negative constraint can actually lead to amazing innovations.
It is. The story of human evolution is full of those kinds of examples. Think about tool making
Right.
or the control of fire,
Yeah.
the development of language. These are all emergences that built on each other, shaping us and our relationship with the world.
It's like a cascade of emergences, each one leading to new possibilities and new challenges.
Exactly. And this process doesn't stop with our biological evolution. It continues into culture and technology, with every invention and idea building on what came before us.
Okay, so we've gone from walking upright to making tools to controlling fire to developing language. What were some of the other big milestones in the emergence of human societies?
Well, one of the most significant shifts was the transition from hunter-gatherer lifestyles to settled agriculture.
Right, agriculture. That's the foundation of civilization.
Exactly.
But why did that transition happen? Was it like a sudden thing or a more gradual process?
It was a gradual process that took thousands of years, and it actually happened independently in several different parts of the world.
Wow, really?
Yeah, and it was probably driven by several factors: changes in climate, rising population densities, and new technologies for farming and storing food.
So it was a mix of environmental and social factors that led to this huge change.
Exactly. And agriculture had a massive impact on human societies. It led to settled lifestyles,
Huh.
larger populations, and more complex social structures.
So it was a kind of social emergence driven by this new way of life.
Precisely. This shift towards agriculture paved the way for villages, towns, and eventually cities.
Cities, those bustling centers of human activity, and let's be honest, sometimes chaos.
That's right. And cities are a fantastic example of emergence themselves. How so? They're complex, dynamic systems, always evolving and adapting. They're hubs for trade, commerce, and culture, where ideas flow freely and innovations pop up.
It's like cities are microcosms of the whole process of universal emergence, right?
Yeah.
We see the same patterns, but on a smaller scale, with individuals interacting and creating something larger than themselves.
That's a great point, and it really highlights how emergence is connected at all levels, from tiny particles to global societies.
This conversation has been a wild ride through time and complexity. But we're not done yet, are we? What about technology? Where does that fit into the story of emergence?
Well, technology is basically using knowledge to create tools and solve problems.
Okay.
And the history of human technology is a perfect example of how emergence drives innovation and progress.
So it's another layer of emergence building on our biology and culture.
Exactly. From the first stone tools to the amazing machines and computers we have today,
Right.
human technology has always evolved through small innovations, each building on the one before.
I'm starting to see how emergence isn't just something from the past, but a process that's still shaping our world.
You got it. And as we continue to explore science and technology, we're likely to see even more amazing examples of emergence, shaping the future in ways we can only dream of.
This conversation has really opened my eyes to how connected everything is.
Yeah.
It's like we're all part of this vast cosmic dance of emergence, from the smallest particles to the largest structures.
That's a beautiful way to put it. And in the next part of our deep dive, we're going to get philosophical.
Ooh.
We'll explore what this all means for how we understand ourselves and our place in the cosmos.
Okay, I can't wait to dive into those deeper questions. This whole conversation has been mind-blowing so far. Welcome back to the final part of our deep dive into universal emergence. It's been quite a journey, hasn't it?
It really has.
Exploring how complexity has arisen from simplicity throughout, like, the entire history of the universe.
Yeah, layer by layer.
Layer by layer.
It's incredible.
My mind is still reeling from all the amazing examples we've talked about, like how those tiny density fluctuations way back in the early universe
Right.
led to the, grand structures that we see today, or how walking upright,
Oh, yeah.
which seems like such a, I don't know, simple change, had such a massive impact on human evolution.
It's amazing how these seemingly small things can have such huge ripple effects, like across vast stretches of time and space.
It really is. As fascinating as all the scientific details are, I'm also really intrigued by the deeper implications of this whole concept.
Oh, yeah.
Like, what does universal emergence tell us about ourselves and our place in the cosmos?
That's a great question.
Yeah.
And it kind of takes us into the realm of philosophy and I'd even say spirituality.
I'm all ears. Let's
Yeah.
dive into those deeper waters.
Okay, so one of the most profound things about universal emergence is that it challenges us to see the world not as a bunch of separate things, but as this dynamic, interconnected web of relationships.
So it's not just about understanding the individual parts, right? It's about seeing how they all fit together into a larger, like, ever-evolving whole.
Exactly. And this interconnectedness, it goes beyond just the physical world.
Wow.
It includes the mental, the social, the cultural, all those layers that make up the human experience.
So it's not just about atoms and molecules. It's also about, like, ideas, beliefs, values, relationships, those things that really make us human.
Exactly. And when we look at the world through this lens of emergence,
Right.
we start to see patterns and connections that we might have missed before, like how neurons interact to create consciousness, how individuals form societies, or different species create ecosystems. These are all examples of emergence at different scales.
Yeah. It's like we're seeing the same principles at play no matter how complex things get.
That's right. And this realization can be, well, kind of humbling.
How so?
It reminds us that we're just a small part of this vast, complex universe that we can't even fully grasp. But it's also empowering. It suggests that we have the potential to shape the future through our choices and actions.
So it's not just about what has emerged, but also what we choose to emerge next.
Exactly. And that leads to a really important question.
Okay, what's that?
What is our role as conscious beings in this whole creative process? Are we just along for the ride, or can we actually steer the ship?
That is a heavy question. I'm not sure I have an answer. What are your thoughts?
Well, I think it's important to remember that emergence isn't like predetermined.
Okay.
It's not a script that's playing out in a predictable way. There's randomness and chance involved.
Yeah, like those density fluctuations we talked about.
Exactly.
Yeah.
But there's also creativity, new possibilities popping up from all these complex interactions.
So we're not just puppets on a string. We have some say in how things unfold.
I believe we do. Our choices, actions, ideas, they all contribute to how the universe unfolds.
A powerful thought.
And while we can't predict the future, we can choose to act in ways that are in line with the principles of emergence.
Okay, so how do we do that? How do we align ourselves with this idea of emergence?
Well, I think it starts with recognizing our interconnectedness. We're not separate from the web of life. We're a part of it. So we have to act with awareness, responsibility, and like a deep understanding that everything's connected.
That sounds like a tall order.
It is a challenge, but I think we're up to it. I mean, just look at us having this conversation, reflecting on our place in the cosmos.
Right.
It shows the incredible potential we have.
You're right. It is pretty amazing when you think about it.
Yeah.
We are the universe becoming aware of itself. reflecting on its own existence, pondering its own future.
And that realization comes with a huge responsibility.
I could see that.
We have the ability to understand emergence, and we can act in ways that shape the future. So what kind of future do we want to create?
Wow, that's a question for all of us to consider. This whole deep dive has really opened my eyes, helped me see the world in a whole new way. I've realized how much we still don't know, but also how much potential we have to learn and grow and build a better future.
I couldn't agree more. I hope our listeners feel the same way.
Well, as we wrap up our deep dive into universal emergence, I'm just filled with this sense of awe and wonder and a deeper appreciation for how everything is connected.
It's been a pleasure exploring this with you.
Likewise. And to our listeners, thank you for joining us on this journey. We hope it sparked your curiosity and inspired you to see the world with new eyes. Until next time, keep exploring the wonders of the universe.